Welcome to this presentation on poorly formed requirements assessment. During this presentation, I'll be using characteristics and rules that are defined in the INCOSE Guide to Writing Requirements to define well-formed design input requirements. Guide to Writing Requirements has been a popular product for many years. To many, it's considered the gold standard for writing quality need and requirement statements. The Requirement Working Group released version 3.1 in May 2022 to update and align the Guide to Writing Requirements with the Needs and Requirements Manual, the Guide to Needs and Requirements, and the Guide to Verification and Validation. And then in June of 2023, then version 4 was released. And this presentation is based on the characteristics and rules that are communicated in version 4 of the Guide to Writing Requirements. At IW 2023, I gave several presentations on the Guide to Writing Requirements. Section 1, which was an introduction and basic concepts. Section 2, characteristics of well-formed needs and requirements. And then a presentation on Section 3, characteristics of well-formed sets of needs and requirements. In May, I gave a presentation to the Chicagoland chapter on Section 4, rules for individual need requirement statements and sets of needs and requirements. I also gave a presentation that gives an overview of the Guide to Writing Requirements version 4 that is also available. Recordings of these 5 presentations are on the INCOSE RWG YouTube channel. There's a playlist for the Guide to Writing Requirements, and these 5 presentations are in that playlist. To get the most from this presentation, it's highly recommended that you first watch the above presentations. If you don't have time to watch them all, I would recommend that you do at least the overview on the Guide to Writing Requirements and also the presentation in Section 4 of the Guide to Writing Requirements. During this presentation, I'm going to talk about an overview of the characteristics of well-formed needs and requirements and the sets of needs and requirements, an overview of the rules for individual need requirement statements and the sets of needs and requirements. And then the requirements that are in this set are based on a case study or a lid installation robot. It's a robot that installs lids on jars. And then we'll go through a detailed assessment and rewrite of a set of poorly formed design input requirements for the LIR. The focus of this presentation is really on applying these characteristics and rules defined in the Guide to Writing Requirements to this case study. There's a lot that needs to be done before defining requirements. Defining well-formed requirement statements is not an exercise in writing, but an exercise in engineering. So as you can see from this diagram, your design input requirements, they're transformed from an integrated set of needs, which are transformed from lifecycle concepts analysis and maturation activities. And there's a whole lot of information that feeds into those activities. So we have stakeholders, they define a problem and opportunity, mission goals and objectives. There's stakeholder needs and requirements that communicate their expectations. We have to consider the risk, what standards and regulations we have to be compliant with, higher level needs, higher level lifecycle concepts, and higher level requirements that could have been allocated to our system of interest. We have to worry about interactions with existing systems. We always have to keep in mind the cost and schedule. And one of the big constraints that we have is the technology. So if we're defining requirements that come beyond state-of-the-art performance requirements, then we have to look at the critical technologies. And this is important in establishing feasibility of our needs and requirements. As such, it's important that we do all this necessary upfront work and analysis to define lifecycle concepts, the integrated set of needs from which our design input requirements are transformed. And it's also important that we understand the context in which the system of interest exists and is well understood. If we're just handed a set of requirements and we don't understand the context from which they came, we're not going to be able to do an adequate job of assessing whether or not that set has the characteristics of a well-defined set of design input requirements. When we're defining requirement statements, the sentence that includes the shell statement, it's important also that we define a set of attributes for each of these statements. While the focus of this presentation is on crafting well-formed requirement statements, it's important that a set of attributes is combined with the requirement statements to form requirement expressions. And you can see we talk about at least 49 different attributes that could be included in your requirement tool and included with the requirements. The Needs and Requirements Manual goes into a detailed explanation of why each of these are included in this set and what the benefits are to including these. The asterisks on here are what we consider mandatory attributes. The key one is rationale. The rationale explains why requirements are needed and additional information that is helpful to better understand the intent of the requirement. Trace to a parent, trace to source. At the higher level requirements that are allocated to lower level parts of the architecture, it's very important we talk about the attributes associated with system verification for our requirements, success criteria, strategy method, and the responsible organization, and the level, the phase, condition of use. And there's attributes to help maintain the requirements, attributes to show applicability and allow reuse, and attributes to aid in product line management when you have different variants of a given system. And the inclusion of these attributes helps contribute to the quality of the requirement statements. We also have a guide to writing requirements 7-page summary sheet. You can show on the left gives the diagram shows that needs and requirements are a common thread that ties all the lifecycle activities together. There's definitions, and we go through the characteristics for individual needs and requirements, as well as characteristics for sets of needs and requirements. The rules are included in here, that set of attributes I talked about. And then there's matrices that tie the rules to the characteristics that they contribute. There's also matrices in there that tie activities defined in the Needs and Requirements Manual and how they contribute to various characteristics as well. This guide to writing requirements summary sheet is available in the INCOSE store for free for all, whether you're a member or non-member. It would be helpful if you have a printout copy of this and have it handy whenever you're developing or reviewing requirements. So the case study that we're talking about, we have a business and it consists of production facilities where customer supplied products are put into jars of various sizes. Labels are applied, lids installed, and the filled jars are packaged for customer pickup. There are 10 different production facilities spread across the country. Each production facility has 20 jar processing systems. Each jar processing system consists of command monitoring software that runs on a computer system in a central facility control room, has an operator that's going to monitor each of the 20 GPSs via the cameras, the C&M software, and overall facility operations, fire, security, shipping, receiving, storage, HVAC, power. You look at the jar processing system, there's a jar installation system that puts empty jars on a conveyor belt. There's a jar filling system that puts whatever the customer's product is into the jars. There's a jar labeling system that puts the label on the jars. There's the lid installation system and the jar removal and packaging system that takes the completed filled jars and puts them into packaging for customer pickup. Our focus is on the lid installation system. All parts of this have been automated except for the lid installation robot, which operates within this lid installation system. There's one lid installation system for each jar processing system. The lid installation system consists of a separate environmentally controlled room with an opening at one end of the room to access jars on the JPS conveyor belt system. The lid installation system includes the lid dispensing system from which the lid installation robot will obtain the lids. There's the maintenance technician that installs lids of the proper size within the LDS prior to a shift start. The operating shift for the JPS is 8 hours a day, 7 days a week, 355 days a year. There's 10 days off for holidays, and operations are constrained to only that single shift. Each of the jar processing systems is assigned to a specific product and jar size. There are a variety of jars of varying heights, lid sizes, and materials that the lid installation robot needs to be able to accommodate. Jars are delivered to each of the lid installation systems via the JPS conveyor belt system. The lid installation robot will replace the existing human lid installers we have now. The LAR must install lids obtained from the lid dispensing system on the jars to the proper torque specified by the jar manufacturer based on lid size and jar material at a rate based on the speed of the jars that are being delivered by the conveyor belt system. The LIR will be controlled and monitored remotely by the facility control room CNM software. This is a jar production facility. External interfaces of the customers, the jar supplier, the lid installation supplier. And of important here is the lid installation system that has the lid dispensing system, motion detection system, and the robot. Looking at the logical architecture of the lid installation system, we have the room itself, the space. We have a lid dispensing system. We have power, lighting, heating, and air conditioning. We have a keyboard access system for the door that leads into the room. We have a motion monitoring system, and then there's the TV system. The lid installation robot itself is going to have power, structure, thermal system for cooling of the electronic components, a communication system to communicate with external systems, and command control system that is kind of the brains of the robot. And then we have the lid handling system that accesses the lids and put the lids on the jar, and jar holding system. Looking at it in a more hierarchical view, you see that the jar processing facility would have had requirements allocated down to the jar processing system, which allocated the lid installation system, which allocated to the lid installation robot. And then those installation robot system level requirements will be then sub-allocated to each of the parts of its architecture. And it's anticipated that the robot will be a very software intensive system. And so that'll be something to be considered when the lower level subsystems have requirements defined for those. So the lid installation robot, is a key part within the lid installation system that's going to be actually installing the lids on the jars. There's the lid dispensing system. It's a new system that's going to be developed to supply lids to the LIR. The interface between the lid installation robot and the lid dispensing system will be defined in an ICD, interface control document. The motion detection system monitors for motion within the lid installation system, provides health and status data and motion alerts to the lid installation robot in flight control room CNM software, the power lighting HVAC, and then the room space and the keypad access system and the cable TV system. The LIR subsystems have power that obtains power from the lid installation system. Power distributes that within the LIR. There's a structure that provides a structure to which all the subsystems are part of and attached. The thermal system includes fans and venting to help control the internal temperature of the parts within the lid installation robot. The communication system enables communication between the lid installation robot and the motion detection system, the keyboard access system, and then the CNM software for supplying data and messages to the software, as well as receipt of commands and messages from the software, the motion detection system, the keyboard access system. The command and control system is the brain, has hardware processors in the software that's contained within the robot, processes commands received from the commands, various subsystems that make up the LIR, monitors, collects health and operational status data from the parts that make up the LIR, sends messages and health and status data to the CNM software, also monitors for critical failures and receives messages from the motion detection system and the keyboard access system via the COM system. The lid handling system gets the lids from the lid dispensing system and grasps it with required force and the proper orientation to install the lid on a jar. Positions the lid to the jar top location, installs the lids with the proper torque, and it's going to provide health and status data to the LIR command control software. The jar handling system grasps the jars, holds the jar with sufficient force to prevent the jar from rotating during the lid installation without moving or breaking the jars. And it also provides health and status data to the command and control software within the LIR. It's important to understand all the external interfaces. These are going to be key parts of the requirements for the lid installation robot. All these interfaces must be identified and defined in some sort of interface control document. And when we're writing interface requirements, they're not complete. We're not pointing to those ICDs that define the interactions. Characteristics of well-formed needs and requirements and sets of needs and requirements. So the characteristics of individual requirement expressions, I'm not going to go through these in detail. I'm assuming that you've watched the previous presentations that do go into detail. The main thing is the formal transformation, set of characteristics, necessary, appropriate, singular, correct, and conforming. And then from an agreed to obligation standpoint that you'd expect in a contract, you'd want your requirements to be unambiguous, complete, feasible, and verifiable. And then we have characteristics of the sets of requirements. So again, from a formal transformation, from the needs, we want our requirement set to be complete. We want consistency within the set and also with other artifacts. And we want to make sure we have a correct set of requirements. From an agreed to obligation standpoint, even though the individual requirements are feasible, we want to make sure that set as a whole is feasible, that it's comprehensible. So when someone looks at that set of requirements, they understand what it is that is going to be developed and what needs to be delivered. And it must be able to be validated that the set of requirements will lead to the achievement of the set of needs and higher level requirements within the constraints, such as cost, schedule, technical, and regulatory compliance with acceptable risk. So we go through the rules really briefly. I'm not going to, again, go into detail. The previous presentation on the rules, hopefully you've viewed that and you have a good understanding of the rules. So they want to be structured, active voice, appropriate subject verb, use of only defined terms, avoid the use of definite articles, use common usage measure, avoid the use of vague terms, avoid the inclusion of escape clauses, avoid open-ended, non-specific clauses, avoid the use of superfluous infinitives, use separate clause for each condition qualification, and naturally correct grammar, correct spelling, correct punctuation. It's amazing how many times those are not followed. You'd think they would be. If you're including logical expressions, use a defined convention to express logical expressions. Avoid the use of the word not. Avoid the use of oblique symbol. You want to keep all your requirements single thought. Avoid the use of combiners and also avoid the use of purpose phrases. Avoid the use of parentheses and brackets containing subordinate text. Enumerate sets explicitly instead of using a group noun to name a set. Use a supporting diagram model or ICD when needed. Avoid the use of pronouns. Don't rely on headings to understand what the intent of a requirement is. Avoid using absolutes. State conditions explicitly instead of leaving applicability to be inferred. Multiple conditions. Rule on classification. Unique expressions. Solution-free universal qualification terms. Rule on range of values. Using measurable performance targets. Define temporal dependencies. Use consistent terms and units throughout your requirement set, as well as all your artifacts that you're developing. If acronyms are used, they must be used consistently and well-defined. Avoid the use of abbreviations. Use a style guide when developing your individual requirement statements, and also have some type of a way of organizing your requirements. When using decimal format, use consistent format and number of significant digits for specification decimal numbers. Group related needs and requirements together, and then structured sets. And so come up with some type of an outline for your structured sets. The rules for needs and requirements discussed in the Guide to Writing Requirements contribute to requirement statements having the desired characteristics of well-formed individual requirements and sets of needs and requirements. A key important point is that while following the rules is necessary, it's not sufficient. The overall quality of the requirements is also dependent on the concepts and activities defined in the INCOSE Needs and Requirements Manual. The rules for needs and requirements discussed in the Guide to Writing Requirements apply to needs and requirements for any entity, no matter the level within an organization or system architecture. So the rest of this presentation is a focus on assessing the quality of a set of poorly formed requirements based on the Guide to Writing Requirements characteristics and rules, discussing these defects, and then proposing an improved version of the requirements that follow the Guide to Writing Requirement rules resulting from requirement statements that have the characteristics of well-formed requirements. So again, the rules are necessary but not sufficient when it comes to meeting the characteristics. Key ones is how do you know when the requirement's actually complete or feasible? Following the rules isn't really going to help with that. We could have the most perfectly formed requirement statement that follows all the rules, but yet that may not be the correct requirement. It may not be feasible. So now we'll get into the details, quality assessment, poorly designed input requirements, some general statements. For the resulting well-formed requirements that I present, you can make assumption that all the terms have been defined in the project glossary or data dictionary as stated in Rule 4 and used consistently stated in Rule 36. The convention we use for terms that are defined is that they're being capitalized. If there's more than one word describing some parameter or something, then the words will be connected together with an underscore and both words will be capitalized. Assume all acronyms have been defined in the project glossary or data dictionary and used consistently. The organization's set of attributes has been defined for each requirement. Due to space limitations, I wasn't able to include attributes. There's a couple where I have rationale to better communicate the point that's trying to be made, but make sure you have the rationale and the verification attributes as a minimum defined. Traceability of each requirement to its need source or parent has been established to help ensure the requirement is necessary. And the feasibility of each requirement has been assessed, as well as feasibility of the set. If you take all of the suggested requirements, put those in a requirement set, you can make an assumption that all these statements are true. Many of the poorly formed requirement examples being assessed would be probably accessible if stated as need statements, like the stakeholders need the LIR to do something, but unfortunately, the writers of those poorly formed requirement statements have chosen to communicate those need statements as shell statements, which is bad practice. That's one of the reasons why in our products we stress defining a set of needs first and then transforming those needs into a well-formed set of design input requirements. Given the large number of rules, it's hard for a person to keep track of them all. What's needed is some type of digital assistant to help the writer assess the quality of the requirements and keep track of all those rules. Fortunately, there are tools that are available as a digital assistant. The Reuse Company, QB Scribe, IBM Requirements Quality Assistant, Gemma Connect Advisor, and there's others. If you have access to one of the digital assistants, they can be a great aid in helping identify many of these defects. Digital assistants address the subset of the rules, are very rules focused, not characteristics focused. Like I said before, you may have a perfectly well-formed requirement by the rules, but they may not have all the characteristics of well-formed requirements. There's some rules that require thinking, and the digital assistants aren't able to do that analysis. So just keep in mind when you use these above tools that they're only doing a subset of the rules and not all the rules. So if they say your requirements are well-formed, they mean only well-formed as far as the rules that they have evaluated your requirements against. There's also now the online AI, large language model applications, ChatGPT, Bing, Bard, and others. While they can be useful, they have serious limitations and limited knowledge of the characteristics and rules and ability to apply them properly, consistently, and reliably. I played around with these, and I'll put in a poorly formed requirement. And so these applications do a fairly good job of identifying some of the defects, but not all. And when you ask them to rewrite the requirement to not contain those defects, it's not able to do so. It'll give you another rewrite that doesn't have those specific defects, but it'll have others. So their usefulness is maybe somewhat helpful, but kind of limited. So none of the digital systems available in the online AI applications will do as the complete assessment is done in the following slides. It's important that you understand that the limitations of these tools and not make the assumption that if the tool finds no defects, that the care requirement sets are well formed, having the characteristics defined. So the first defective requirement, the maintenance technician will provide a daily supply of lids to every installation robot at the beginning of the shift. So looking at this, you can see that's written a statement of fact will of what the maintenance technician will do rather than a requirement shall on the lid installation robot. When writing requirements, we must use the proper term shall that makes it clear it's a requirement rather than a goal, should, or statement of fact will. We want to ensure the subject and verb of the needed requirement statement are appropriate to the entity to which the statement refers. The requirement should be written on what the LIR is required to do and when, not on the maintenance technician who provides the lids to the lid dispensing system, which then dispenses the lids to the LIR. We need to make sure we pay attention to the correct spelling. Maintenance and will are not spelled properly. Avoid the use of absolutes like every. Use each instead of every when universal quantification is intended. Because there's an interaction between the two systems, this is going to be an interface requirement, which must refer to where the interactions between the lid dispensing system and the lid installation robot are defined, i.e. an ICD. Else the requirement's not complete, not verifiable. In this case, we'll write this as two requirements. The first one says the LIR shall obtain lids from the LDS as described in LAR LDS ICD. And the second one, the LIR shall obtain lids from the LDS per the timing defined in JPS ICD. This is an overall requirement that when designing the robot, it needs to be able to get lids from the lid dispensing system per that timing in order to be able to put the lids on the jars as they appear. Defective, it must be powered up quickly once commanded. Some of you are probably laughing at this, but I see requirements like this. It's kind of sad. We want to avoid the use of personal and indefinite pronouns. Convention states requirement should be indicated by a shall rather than must or may. So the LAR shall. We have to identify what power up means. And this must be a defined term. Given the LIR must respond to a remote command to power up, it's probably assumed that it's in a sleep state, able to listen for that command. So it's not totally powered off. This needs to be defined. Commanded by whom, in what form, using which media. This action involves the interaction with another entity, so it's an interface requirement and must point to where the interaction is defined, ICD, else the requirement's not complete. We want to avoid the use of vague terms like quickly, else the requirement's ambiguous and not verifiable. We want to define temporal dependencies explicitly instead of using indefinite temporal keywords such as once, else again the requirement's ambiguous and not verifiable. Performance value must be included as to when the power-up sequence must begin once the command is received. Function requirements must include a performance value, else the requirement's not complete nor verifiable. An improved requirement is the LIR shall perform the power-up sequence within 1 second of receipt of a power-up command from the FCR CNM software having the characteristics defined in the FCR ICD XYZ. The power-up sequence now is capitalized to indicate that's a defined term. Power-up command is a defined term as well. And then the interaction, in this case, understanding what the characteristics the commands received are, is included in the requirement statement. The next requirement, normally a self-test should be performed at power-up. And that's a good thought. It's a good need statement. The stakeholders expect self-test to be performed at power-up. But from a requirement statement, it's definitely not a good requirement. As passive voice, use the active voice when the responsible entity clearly is identified as the subject of the sentence. It's written as a goal should rather than a requirement shall. We must use the proper term that makes it clear that this is a requirement rather than a goal should or a statement of fact will. Avoid the use of escape clauses like normally, which are ambiguous and not verifiable. Self-test must be clearly defined in the project data dictionary and glossary as to what is meant, what is to be tested, what constitutes success or failure. A performance value must be included as to when the self-test must begin. Function requirements must include a performance value, else the requirement is not complete. The results of the self-test must be reported to the CNM software. Approved written as two requirements. The LIR shall perform a self-test within 1 second after power-up sequence is complete. Self-test is capitalized, so we know that's defined somewhere exactly what a self-test means, and the power-up sequence the same way. And then the second requirement, the LIR shall report the LIR health and status to the CNM software as defined in the ICD within 1 second of completion of the self-test. The system health and status message format shall follow the structure specified within the FCR software ICD. The requirement's not written on the LIR, rather it's written concerning the format of the message as defined within an ICD. All requirements within the LIR set must be written on the LIR. Ensure the subject and verb of the need and requirement are appropriate to the entity which the statement refers. Within the ICD, the use of shall should be avoided. ICDs contain definitions of specific interaction between entities. So in an ICD, you'd have something that said the system health and status message format is shown in table XX. Improved, The LAR shall report LAR health and status to the FCR C&M software using the message format defined in the FCR ICD XYZ. The supplied lid shall be used by the LAR. This is written in passive voice. We want to avoid that. We want to use active voice with the responsible entity clearly identified as the subject of the sentence. The LAR shall. The specific lids that will be used must be clearly defined as to which lids and their characteristics is defined in the lid specification, else the requirement is not complete, it's ambiguous and not verifiable. So an improved version is the LIR shall install on the jars lids having the characteristics defined in lid specification lid 1234. This requirement is all about specifying the specific lids that the LIR has to interact with. And to do that, it needs to know what the characteristics of those lids are. And that's what this requirement does. The LHS and JSS shall be able to install a lid on supplied jars. The lid handling system, jar handling system are LIR subsystems. Given this is the LIR set of requirements must be written on the parent system, the LIR. We don't want to have any requirements of the subsystems included within the system level set of requirements. Avoid superfluous infinitives like be able to, which are ambiguous. Requirements clear if the phrase is not included. Shall install versus shall be able to install. The specific jars that the lids will be installed in must be clearly defined as to which jars and the characteristics as defined in the jar specification. If the jar specification is not referred to in the requirement statement, the requirement is not complete, it's ambiguous, and not verifiable. So an improved version, the LAR shall install lids on jars having the characteristics defined in jar specification jar 1235. Again, this requirement's purpose is to specify the characteristics of the jars of which the LAR is going to install lids on. The automated machine shall install lids on jars about every 30 when it can. So when we're writing requirements, we must be consistent and use the terms. In this case, we're writing requirements on the LIR. So we need to use LIR consistently throughout the LIR requirement set rather than any synonyms like automated machine. In the LIR set of requirements, all requirements should begin with the LIR shall. About is misspelled. Avoid the use of vague terms such as about, which is ambiguous and not verifiable. Avoid the use of escape clauses like when it can, which is ambiguous and not verifiable. When stating quantities, common units of measure must be used. 30 is a value that must have proper units included. 30 of what? Seconds? Because the LIR is interacting with an existing system, the timing is defined in that system's ICD. Rather than pulling out the value from the ICD, it's better to refer to the ICD that defines the timing. That way the number is only maintained and configuration controlled in one place. If you pull the numbers out, then that number is in multiple places and can become out of sync. So an improved version of this requirement, the LIR shall install lids on jars per the timing defined in JPS ICD XYZ. The whole purpose of this requirement is just to have a generic timing requirement, tell the LIR when you're doing the lid installation on jars, the designers know that it has to be able to do so based on the timing of the jars being delivered per the conveyor belt system. The LIR shall be capable of installing lids on jars as positioned on the conveyor belt. LRI is misspelled, which should be LIR. Avoid the use of superfluous infinitives like be capable of, which are ambiguous. Requirements clear if the phrase is not included. Shall install is a lot clearer than saying shall be capable of installing. Those extra words just aren't needed. The use of parenthetical phrases must be avoided. Because the LIR is interacting with the existing system CBS, the conveyor belt system, it must refer to the ICD that clearly defines the exact position on the jars on the conveyor belt. An improved version of the requirement, the LIR shall install lids on jars positioned on JPS CBS conveyor belt as defined in JPS ICD XYZ. And you see lids is capitalized, jars is capitalized. So all the capitalized terms are defined in your glossary. The jar's position should not move on the conveyor belt during lid installation if possible. Written as a goal, should. It must be written as a requirement, shall, on the entity to which it applies. The LAR shall. Avoid the use of the word not. Rather than not moved, you could use shall maintain. The allowable amount of movement is not specified, thus the requirement is ambiguous, not verifiable, not complete. Avoid the use of escape clauses like if possible, which are ambiguous and not verifiable. An improved version, the LIR shall maintain the jar position within plus or minus 0.01 inches on the conveyor belt during lid installation. Note, when you're using decimals, make sure you're consistent in the number of significant digits. Lids shall be installed on the jars with a torque consistent with jar size and material, such that the jar is not broken, a good seal is established, and a human can easily remove the lid without special tools or aids. So this is written passive voice. It's written on lids shall be, but all the requirements should be written on the responsible entity doing the action, which is the LIR. So we want the LIR shall as the requirement. The actual torque value is consistent with the jar size of material, must be clearly defined, else the requirement is ambiguous, not verifiable, not complete. Statements of purpose rationale must not be included in the requirement statement, but rather included in the rationale attribute. An improved version, the LAR shall install lids on the jars with the torque within the torque ranges specified in Table 6 for the jar size and material. Here that we have rationale. Proper torque must be used when tightening the lids such that the jar is not broken. A tight seal is established while enabling a person to remove the lid without special tools or aids. And one thing to notice is we're referring to a table. Given that a table contains multiple parameters defining the required torque based on jar characteristics, size, glass, or plastic, someone decided to address the characteristic C5 singular and the rule R18 single thought, there should be multiple requirements, each addressing a single parameter. In doing this, others have a valid concern associated with characteristic C13 comprehensible. If I did a separate requirement for each parameter, I could have a whole lot of requirements in the requirement set, making it difficult to get through and read, while the single requirement referring to the table makes it much more comprehensible. No matter which approach is taken, the system must be verified for each of those parameters. And it's up to the organization to decide which approach they choose to take and then be consistent in the application of this approach. The robot shall be available to install lids on jars during the normal operating shifts year-round. When writing requirements must be consistent use of terms, must use LIR consistently throughout the LIR requirement set rather than any other synonyms like robot. In the LIR set of requirements, all requirements should begin with the LIR shall. As written, be available to a superfluous infinitive, which should be avoided, else the requirement is ambiguous, not verifiable. As written, the requirement really is ambiguous. It's not clear whether the intent is for this to be an availability quality requirement or requirement defining shifts in which the LIR must install lids. The project team should decide if both perspectives should be reflected within the requirement set. Having a rationale statement would help understand the intent. Improved, assuming the requirements about the shift in which the LIR must operate. The LIR shall install lids on jars during the shift defined in the JPS ICD 355 days per year. And rationale, the LIR must install lids during the JPS operating hours. Improved, assuming the requirements about the quality characteristic availability. The LIR shall have an availability of at least 0.98% during JPS operating hours. Notice I've capitalized the word availability, saying that we've defined exactly what we mean by availability in our glossary. Define each quantity with a range of values appropriate to the entity to which the quantity applies and against which each entity will be verified or validated. When you use at least 0.98% rather than the stated absolute of 0.98%. Note the qualifying phrase during JPS operating hours is necessary, as that is the only time the requirement applies. You could ask the question, is an availability requirement really needed? We have requirements concerning that the robot must install lids during the operating hours specified. We also have meantime to repair requirements, and we have lifetime requirements. It may be that this availability requirement in this case is not needed. We always want to look at the requirements and say, why is this requirement here? Is it covered by other requirements? And it doesn't really need to be stated. So it's important to ask those kind of questions. Okay, let's take a break. We've been at this for a while. When you get back from your break, you can pick up with part 2 of this presentation.